All right, guys, this is May 8th, and we're covering section 7.1, so we're getting on. Last chapter, you guys. Make sure you have your calculator out. For this one, we're going to be doing some matrices stuff. Some of it by hand, some of it on the calculator. Make sure you have your calculator to pay attention. So as we go, some of the first stuff's pretty straightforward. Determine the size of each matrix, then identify the entry located in the second row in the first column. So the size is the dimensions, how many rows by how many columns. So this one has 3 rows and 2 columns, so I would call this a 3 by 2 matrix, okay? And then identify the entry located in the second row, first column. That's the number 1, okay? Over here, I've got 1, 2, 3 rows, 1, 2, 3, 4 columns, so I would call this a 3 by 4. The entry located in the second row, first column, is that negative 4 right there, okay? Straightforward, that's not going to be too terrible. Name the diagonal entries of each matrix. So you start in the top left and you go down diagonally. So the 1 and the negative 3 are the diagonal entries here. Here, the 0.2, the 0.3, and the 0.6 going right across that main diagonal. Okay? Example 2. Form the augmented matrix for each system and then name the diagonal entry. So the augmented matrix is taking a system of equations and making it into a matrix. So you get something that looks like this. So the first row has a 2 and a 1, and then augmented, we'd put a dashed line to kind of represent the equal sign, and then an 11 on the other side. The x here is negative 1 and then a 3, and we're just listing the coefficients, and then a negative 2. And of course the diagonals here, guys, are going to be, I'll just circle them this time. The 2 and the 3 are my diagonal entries, okay? Over here, I've got 3 equations and 3 unknowns, so I'm going to need 3 rows. My x is a 1/2, my y is a 1, my z is a 0, and on the other side of the equal sign, the constant's a 5, okay? My x is a 1 in the second row, my y is 2/3, my z is 5/6, and there's an 11 on the other side. In the last row, no x, no y, my z is a 1, and my constant term is a 6 on the other side. And then the diagonal entries for this one are those right there, okay? These aren't too bad, just rewriting it using matrices, which is going to help us solve some problems in the future. So write the system of equations corresponding to each matrix, then solve the system using back substitution. So this first one really means 7x minus 4y equals 8, and negative 2y equals negative 3. Okay, so back substitution, I can solve this one, divide both sides by negative 2, and I get 3/2 for my y coordinate. Then I need to put that 3/2 back into this equation. So negative 4 times 3/2 is negative 12 over 2, or negative 6. So I add 6 and I get 14 divided by 7. I get a 2 for that one, okay? Over here, I've got x plus 4y minus z equals negative 10. I've got y plus 4z equals negative 1, and then I have z equals 2, okay? Well, that last one, that's easy, right? Z is 2. Now I'm going to back substitute. If I put that 2 back in here, 4 times 2 is 8, so I got to subtract an 8. Negative 1 minus 8 is negative 9. Now I've got my y and my z, so 4 times negative 9 is negative 36. Minus 2 is negative 38, so I add 38, and I get 28, okay? So that's all they're asking you to do in that scenario. Okay, I guess I could have put it on this page, but I had room. So elementary row operations, we did this when we were solving systems of equations. This is just as it pertains to a matrix in general. So changing the order of the rows, so I can put the second row first, the third row first, however I want to do that. I have a reason for doing that as we get going. Replacing a row with a non-zero constant multiple of that row. So I might multiply a row by 2 or 4 or something like that. Replacing the row with the sum of 2 rows from the matrix. We do this quite a bit. I might multiply the first row by 2 and add it to the second row, and then replace the second row with the result. Okay? we want to solve a system by triangularizing. In other words, try to get it so that I have x, y, z in the first row, only y and z in the second row, and only z in the third row. Okay? Write it as an augmented matrix. Use row operations to obtain zeros below the first diagonal entry. Use row operations to obtain zeros below the second diagonal entry. Continue until the matrix is triangularized, and then back substitute to solve. And so we'll take a look at an example like this. So they want us to use Gaussian elimination, which is those elementary row operations, to get it in triangular form and then to solve it. Okay? So we're going to take that system, we're going to make it into an augmented matrix first. Okay? And then I'm going to work from there to get it in triangular form and get my solution. Okay? So on the next slide here, we're going to start with the augmented matrix in that. So I've got 2, 1, -2, -7, 1, 1, 1, -1, 0, 2, -1, -3. Okay. And now my goal typically is to get a 1 in the upper left-hand corner. It's easier to work with everything if I can do that. So I'm going to interchange. So I'm just going to write row 1 and then kind of an arrow going both directions to row 2. Okay? And so that simply means I want row 1 to have a 1 out front. So I'm going to put row 2 where row 1 was. And then the row 1 is going to go where row 2 was. So that's all I'm doing here. Not changing row 3 at all. Okay? Okay, so now I'm here. The next thing they said is to get zeros below that first diagonal entry. Well, I've got a 0 down here, but I don't there. So I'm going to take -2 times row 1, and I'm going to add it to row 2. So that'd be -2 plus 2. That'll give me that 0 that I'm looking for. Okay? So I'm going to just use a different color here. So the first row I'm going to leave alone. And then the second row, -2 plus 2, that's a 0. -2 plus 1, that's a -1. -2 plus -2, that's a -4. And -2 times -1 is 2, plus -5 is or plus 7, -7 is -5. And then I'm going to leave that third row alone. Okay, so I've got zeros below that first diagonal, which is what I was shooting for. Then I would like this to be a +1, so I'm just going to take row 2 times -1. Okay, so I'm going to leave row 1 alone. Everything in row 2 is going to have the opposite sign, and I'm going to leave row 2 alone, or row 3 alone. Okay, now I need this to be a 0 right here, so that's going to give me, I'm going to go -2 times row 2 and add it to row 3, so -2 plus 2 will give me a 0 there. Okay, okay, so row 1, not going to touch it. Row 2, 0, 1, 4, 5. And then that last one, so 0 plus 0, -2 plus 2 is also 0, -8 plus -1, is -9, and then -10 plus -3. Oh, what did we do here? I just got to make sure I didn't make a mistake here. 1, 5, -3. 1, 1, 1, -1, 0, 1, 4, 5, 0, -2. So row 2 times -1, and then okay. Bear with me for a second here, you guys. 1, 1, 1, -1, 0. Oh, here's my mistake. This guy was a negative all along, so this should have been a negative, which means I'm going to multiply by 2 and add. Okay? Sorry about that, you guys. Okay, so then I've got 8 plus -1, which is -7, and I've got 10 plus negative 3. Which is 7. This one should have been a positive 2. Okay, and so then I've got, oh yeah, I was adding positives there, so that's a, no, this was, sorry. Oh, sorry you guys. Okay, so 4, this was a 1, so that, this was that negative 1. So I got 8 plus negative 1, which is negative 7. And then I got, yeah, I got positive 7 and positive 7, sorry. Okay, so then I got 7z equals 7. Okay, let's do this in black here. So 7z equals 7. So z is 1. Okay, and then this equation here, if I go up here, this is going to be y plus 4z equals 5. Well, if z is 1, that's a 4, subtract a 4, we get a 1 here too, okay? And then I go back to the first equation where I've got x plus y plus z equals negative 1, okay? Well, y and z were 1, so 1 plus 1 is 2. I subtract 2, and I get negative 3 down here. So I apologize for here. You really got to be careful with your negatives. You see what's happening if you don't. I forgot the negative at the beginning, and it screwed me up the rest of the way. So be really careful, okay? These are there's only going to be 1 or 2 that I ask you to do by hand like this. The rest of them we're going to do on the calculator. And I'll show you how to do that in a bit here. Okay. So Gauss-Jordan elimination, get it into reduced row echelon form. This is going to be a calculator. We could do it by hand, but we've got a calculator to do it, so we're going to do it, okay? So what we're going to do for 5 is we're going to be able to put this in the calculator and ask the calculator to put it in reduced row echelon form. And I'm going to show you the screens for that. So you're going to go to, you're going to be on your main screen. You're going to go to the matrix button on your calculator, which your matrix button is above the x to the negative 1 button, so second matrix, and you get these 3 menus. You go over to the math menu and you scroll all the way down until you see RREF, reduced row echelon form, okay? And so then you'll have this on your screen. If you press alpha zoom, then it asks you what dimensions you want for your matrix. Well, all of these equations are going to have 3 equations and 3 unknowns, so I need 3 rows and 4 columns. I press enter, and then it allows me to enter these, and I physically have to put the numbers in. So 2x plus 1y minus z equals negative 4. So I go ahead and put them in, and then I press enter, and the calculator gives me that last row. Well, guess what, you guys? That means that x equals 1.5. It means that y equals negative 2, and it means that z equals 5, okay? And that's without me having to go through and do it all by hand. So make sure you double check on those, how to get those screens. If you don't, ask, email me, Google Meet, do whatever we need to get that figured out, and I'll walk you through it, okay? So that being said, we can do a lot of this pretty quickly without having to do it by hand, okay? So example 6, same thing. I'm going to put it in the calculator, reduced row echelon form of that matrix, same way I did in the previous screen. But now for this one, I get all zeros across the bottom, which means I have infinitely many solutions, but I have to write a prototype for how to find these solutions, okay? So I'm going to set my order triple here. And in these cases, when we've done this before, I'm going to just let z be z. In this previous row, I have y minus 3z equals 2. And if I were to solve for y, I'd add 3z to both sides, and I would get 3z plus 2. So that's what my y is going to be, okay? So y equals 3z plus 2. And then in the first row here, I have x minus 2z equals 1. If I solve for x, I get 2z plus 1. So I'm going to put 2z plus 1 in place of my x, okay? So if you have an infinitely many solutions, so one whole row is 0, 0 does equal 0, then you do have to write something down though. You can't just write all real numbers, you have to write a blueprint for this. Start by letting z be z and then solving for each of those equations in the previous rows, okay? Example 7, a couple more unique situations here, you guys. So for part A, same thing. I'm going to put it in reduced row echelon form, and I'm going to ask the calculator to solve it. Now, for this one, look what you get. You get 2 rows that have all zeros, which really means you can put anything in that satisfies that first equation. So here's how you're going to write that. Okay? You're going to say all x, y, z's such that, and that's just a vertical line, x minus 3y plus 2z equals 1, which is really just copying that equation. That's all you have to write. There's no other way to write a blueprint for that one. Okay? Now, the second one, you'll notice in the last row you have 0 equals 1, because this is augmented, so there's an equal sign right there. 0 never equals 1, you guys. So this one is just no solution. And it's because of that bottom row where 0 equals 1. Okay? All right. A word problem, and then we'll get you going. So a museum purchases a famous painting, a ruby tiara, and a rare coin for its collection, spending a total of $30 million 1 year later. Or $30 million. 1 year later, the painting has tripled in value, while the tiara and the coin have doubled in value, for a total of $75 million down the road. Find the purchase price of each if the original price of the painting was $1 million more than twice the coin. Okay, so how are we going to do this? Okay, we need to write a system first. Well, it said that painting, the tiara, and the coin, the first year sold for $30 million. Okay, and then it said if we tripled the cost of the painting tripled, and the coin and the tiara doubled, and then we had $75 million. Okay? And then it said that the cost of the painting was $1 million more than twice the cost of the coin. Well, now I've got 3 equations and 3 unknowns, and I can solve this. So what I would have you do is go back into your calculator screen, reduce row echelon form. We've done this before. The first row has all ones, 1, 1, 1, and then a 30 on the other side of the equal sign. The second row, 3, 2, 2, and a 75 on the other side of the equal sign. This one's a little trickier though, because it's not set up in columns. The P is here, and that's a 1. There is no T. The C is on the other side of the equal sign, so I would need to move it over and get -2 for C, and then the 1 would stay over there. Okay? And when you do that, okay, you're going to get this. 1, 0, 0, 15. And then the tiara 0, 1, 0, 8, 0, 0, 1, 7. Okay? Which means ultimately that the painting was worth 15 million originally, the tiara was worth 8 million originally, and the coin was worth 7 million originally. So you got to be able to set up a system of equations from what you read in the word problem, and then you can solve it on the calculator. That's just fine. Okay? All right, you guys. So there's the problems here. So 5 through 15 odd. And those ones you can do by hand. There's not a lot of them, but you can do them by hand. But the 27 through 48 multiples of 3, use the calculator. Use reduced row echelon form. Do not do those by hand, you guys. Okay? Again, any questions, please stop by my office hours or email me. Okay? Thanks.